Speed and velocity. Speed is the rate of change of distance. I.e., how much distance is covered in each second. Or in formula terms, speed, which confusingly still has a symbol v, is distance divided by time, or sometimes that is written as d equals vt. Because distance is a scalar quantity and time is a scalar quantity, speed is also a scalar quantity. Velocity, on the other hand, is the rate of change of displacement. I.e., displacement per second. Also has a symbol v. Displacement, remember, is s, so we can write that as v equals s over t, or s equals vt. And velocity is a vector quantity. The difference between these two can be shown quite clearly in a simple example. If an orienteer starts at a particular point here, put S for start, and let's say they trace out, and their path takes them 4 kilometres to the east, and then 3 kilometres north. I'm actually drawing these with a ruler. I know they don't look that straight. Seems to be a funny thing about the screen on the iPad. And that's our start and that's our finish. And remember the resultant displacement, I'll put in my north line as well. The resultant displacement would take them directly from start to finish. And I'll put a double symbol on that. So if you look here at distance, our distance d is 3 plus 4, 7 kilometres. Direction doesn't matter. The displacement, we'll need to use a bit of Pythagoras and trig. Now I've chosen numbers to make it nice and simple, and the focus of this isn't about calculating these, so you can check out the previous video for that. But you should be able to work out that hypotenuse is 5 kilometres, and this angle in here is 37 degrees. So the displacement is 5 kilometres, and remembering that a bearing is clockwise from north, if I draw a north line in there, then it's that angle in there that I want as a bearing. So that's 90 minus 37, which is bearing 053 degrees. And therefore the speed, the average speed for this journey, if for argument's sake it's 2 hours, let's write up our time, 2 hours, then our average speed, be bar above, remember, for average, would be 7 kilometres divided by 2 hours, 3.5 kilometres per hour. There's no need to convert back into metres per second. You can use kilometres per hour if that's the dimensions you're given the data in. V for velocity this time is s over t, and it's only the magnitude of the velocity that we divide by the time. So the time of 2 hours, that gives us 2.5 kilometres per hour, but we use the same bearing or direction as the displacement. And so our average velocity is 2.5 kilometres per hour, bearing 053 degrees.